Good afternoon, good morning, good evening to all our speakers and our participants. This webinar is the second in the series of webinars organized by Center of Water and Sanitation, CEPT University, in partnership with Global Sanitation Center of Excellence, IIT Palakkad, Pekin, and Bill and Melinda Gates Foundation on ISO non-sewered sanitation standards. Non-sewered sanitation practices are followed in many geographies all over the world, whereas standards for these practices are limited to a few of the geographies. And ISO as an organization has developed standards all across the value chain, which helps address the challenges in other geographies. And this webinar would be an attempt to disseminate information on one of the standards, that is ISO 3500. We already had an overview of all the four ISO non-sewered, all the three ISO non-sewered sanitation standards, plus the other two associated standards in the last session, which happened in 12th September. And this is the second in the series where we'll be deep diving into ISO 3500. So with that note, I would request Dr. Roshan Shrestha from Bill and Melinda Gates Foundation to give his initial remarks. Roshan ji, please.
Thank you, sirs. Very nice to meeting you all. After 2 months, again, we are meeting here to discuss an ISO standard. So exciting, because last time we have more than 200 people join. I'm sure colleagues are coming, joining. It's already 70, 80 people are already here, already joined this. I think today is going to be much more interesting one, because the last webinar was, we got some kind of overview about the all four ISO standard to really understand about the definition and why we are working on that, and so on and so on. But now today, I believe it will be specific discussion is going to happen. Son, thank you so much for joining. Chris and Isley, right? So for coming here to really give us the idea about the ISO 30500, because it is also quite important in the sense of, because we all now talking about the, we really need to look at the public health aspect. We really need to look at the pathogen killing technologies and to improve the public health. So at the same time, there are a lot of technologies are coming in the market, and but still the standard, what kind of thing need to be done, and how can what kind of standard need to adapt it, that's not really clear to most of the stakeholders, including the business company as well. So adopting this ISO 3500, definitely it is a way forward. It will be good for the people like us who really implement, support the policy, formulation, and so on and so on. At the same time, it will be also good for the private sector who really coming to the business. And regulator also, it is very important, because they can really enforce that this kind of standard, so that the product whatever coming in market, that can be the comply with the standard, so that we will have the right technology in place, so that the sanitation will be improved on the ground and public health can be improved. Thank you so much for everybody joining here. And Son, we are very much looking forward to hearing from you, please. So welcome once again to all colleagues. Now let's go.
Now we will have a brief introductory video by Dr. Dinesh Mehta from CWAS. Let's please play.
Hello, good evening, good morning, good afternoon, wherever you are. On behalf of CWAS and all other organizers of this webinar, it's my pleasure to welcome you to this second in the series of webinars that we are hosting on the ISO standards for non-sewered sanitation. As we have said in the previous webinar, that bulk of the developing world, the cities and settlements have non-sewered sanitation. The technology on the containment part, that is the toilet part, has remained unchanged for over a century. So in this ISO 3500 that we will discuss today, we are looking at a transformative technology for the containment and the standards that are applicable for this kind of toilet designs, etc. We have a range of speakers who will talk about the standards and then the testing. So welcome again to this interesting webinar, and we hope that we will continue to have your attention for the future webinars as well. Thank you. Bye.
Thank you, Dineshji. Let's move into the details of this ISO 3500, which deals with the general safety and performance requirements for standards for design and testing of prefabricated integrated treatment units. So first we will delve into the need of this ISO standard as such. Why is ISO 3500 actually needed? Our expert, Sun Kim, who is a consultant as well as former senior program officer on the WAT team of Bill and Melinda Gates Foundation, will be delivering this lecture to us. Sun Kim has focused on development and implementation of international standards for non-sewered sanitation for the developing and the developed world alike, and its application to customers that really do not have access to these sort of facilities. Sun is currently the chair of the ISO PC 305 Working Group 1, as well as the convener. Sun graduated from the University of Washington in 1984 with mechanical as a majors. Over to you, Sun. Please educate us on the need of this standard.
Thank you for the very nice introduction. Wow, 1984. I think most people weren't even born then, so I must be a fossil. But hey, really, thank you for the introduction, and really looking forward to going into more details following the kind of the high-level introduction that was done 2 months ago. And I just want to note that we'll still just be scratching the surface. You know, even in an hour and a half, 2 hours, we can get into some more details. But you know, there are you know, I notice on the participant list there are several individuals that have been involved in the development of the standard, and literally it's you know, the span has been years, but the amount of hours each individual has put in is significant. So there will be some additional resources available that will be shared towards the end, and hopefully those links will work when the presentations are sent out. And so next slide, maybe we can go to the, yeah. And if we can just go to the next slide. So I have a question. I hope it's not too personal, but we're here to talk about toilets. So what kind of toilet do you and your family use, whether at home or work? Whether you sit or squat, wash or wipe, you are really fortunate if you have a very nice water flush toilet. But where does it go when you flush? Next slide, please. Does it get treated like in the wastewater treatment plant that you see to the right, or does it just go directly into the environment? So the real question is, are the outputs safe for human consumption, or for humans and their health, and to the environment as it goes in? So I always think of it as, it's not just about where you go, but about where your waste goes. So it is a fundamental issue, and I think most of you on this call are probably familiar with that. If you can go to the next slide, please. So according to the WHO and UNICEF Joint Monitoring Program's 2023 report, 2.2 billion people lack access to safely managed water services. And even more, 3.5 billion people lack access to safely managed sanitation. That's almost half the population of the world today. And there's also almost 500 million people still open defecating, really not by choice, but because that's really their best option. And that's really a problem. And then also 400,000 or more young children die every year from preventable diarrheal diseases. I used to work at Boeing for almost 3 decades, and airplane safety was a really important aspect. And when an airplane or two would crash because of some problem, killing 300, 400 people, it would just make the world news. And yet here are 400,000 babies dying of preventable diarrheal diseases every year. Yet not a lot in the news. It's really crazy. And then women and girls, certainly the impact to women and girls are particularly pronounced. They're imprisoned by daylight because sometimes that's the only, the dark is the only time that they get to relieve themselves out of modesty. And then in schools, I know like lack of access to safely managed sanitation, especially when girls start to menstruate, is a huge issue. Having 2 daughters of my own, I know what a big deal it is to start menstruating and then also not to be able to take care of yourself. Wow, what a burden. And then also the burden for caring for sick typically falls on women and girls, and also pregnant women when they're infested with diseases such as hookworms, hugely impactful in a negative sense. Next slide, please. So often the solutions for current on-site sanitation include septic tanks with a drain field, some treatment, or pit latrines, or sometimes just worse, just maybe open defecation. And so we know that the problems with existing on-site sanitation, they're often built on site. So treatment is also typically minimal. And then also the build variation, the stick build can impact any treatment that is supposed to be doing and its usability, dependent on local conditions for drain fields and for soaker pits. It all depends on the soil conditions, whether it holds it for long enough, but also drains it appropriately before the pathogens possibly gets into an adjacent water source, whether it's a borehole or whether it's surface water. And can you go back to the prior slide? Sorry. And also, like I said, does not treat on-site. Sometimes may have aerobic or anaerobic digestion, but typically is incomplete, requires regular desludging. And of course, where does the desludged material go? Full of pathogens and environmental pollutants. So often very expensive to install, maintain, decommission, and also the cost of human health and environmental health. Thank you. Next slide, please. So this is just a quick picture of some community scale toilet treatment systems that I'll get into a little bit later. And then the next slide shows the household scale, really appliances that you would be very happy to have inside your home. Unlike a pit latrine, that there is no way you would like to have a pit latrine anywhere near your home. In fact, typically you put it as far away as possible. So next slide, please. ISO 30500 compliance systems addresses the problems with current on-site sanitation systems. So they're intended to be prefabricated. So it minimizes the variations in performance of the systems. And then also the systems can be certified, which Mr. Chris Chan will be getting into a little bit more. The standard requires that the systems operate in the majority of climates and geographies. So these are the temperatures, the relative humidity, and the altitudes that these systems are required to work, as well as being watertight, and there's additional requirements for technical tightness. It's expected to fully treat on-site. So it's not just a toilet, but the treatment system. And it's treats for human enteric pathogens. These are the fecal oral transmitted diseases, and also environmental parameters for the effluent, the liquids that come out of the system, gas emissions, odor, and noise. And there should be no need to desludge. It should require no periodic desludging. It will release some liquid, assuming that it's not evaporating, but those liquids will be safe for human and environmental health. There might be some removal of ash or some dry solids once the system has operated, but that's probably going to be very infrequent. And then also, because these are intended to be integrated factory-produced products, the mass scale production is expected to reduce the cost on a per unit basis, as well as installation. Next slide, please. So this is my final slide. So it is the implementation of these quality standards that is one of a number of factors, and these are just some of the factors that will revolutionize the non-sewer sanitation industry. But the implementation of those quality standards and being able to certify systems will make readily available products that should drive down the cost, again, through mass production. And I will talk a little bit later about how a quality standard, like an ISO standard, is supportive of regulatory environment, and I'll give you some examples of that. So with that, I'll hand it back to Dr. Sarosh. Thank you very much.
Thank you, Sun, for educating us on the impact possibly that would be generated, as well as the condition of the existing systems at large. Now we will move on to the
you just muted, Dr. Sarosh. Yeah.
I think there was an issue. I mean, I got muted. Now we'll go into the scope of the ISO 3500 standard, which will be delivered by Leslie McDermott from the American National Standards Institute. This, I mean, due to certain circumstances, Leslie has provided us a recorded version of her session as a video, which we'll be playing out for the audience. Leslie leads ANSI's international development activities, including the advocacy and the program development to improve the national quality infrastructure, as well as strengthen US market access across geographies and emerging economies. Leslie manages the implementation of projects such as the Standards Alliance, a public-private partnership with USAID designed to assist developing economies in implementing their commitments under the World WTO Technical Barriers to Trade, this is a TBT agreement. Leslie also acts as a liaison between government, standard bodies, industry, and other affected organizations in a multi-stakeholder effort to help assure that the projects affecting trade and infrastructure development in these economies have a meaningful impact. Leslie holds a master's degree in international relations from Royal Holloway University of London, as well as a bachelor's from Boston University. She is also a certified project management professional. Let's play the video by Leslie, please.
Hello, my name is Leslie McDermott, and I'm from the American National Standards Institute. Thank you very much to the organizers for allowing me to send a recorded presentation, and I'm very sorry that I couldn't be with you all live on the webinar today. But I'm going to share a little bit of information and background on the development of ISO 30500 and the organization that it published the standard, ISO, to serve as a foundation for hearing more about the standard and the technical contents later on in today's webinar. So just to start, by way of background, as I mentioned, I'm from the organization ANSI, or the American National Standards Institute. And ANSI leads standards and conformity assessment activities for the United States of America. We are a private sector nonprofit organization that was founded more than 100 years ago. And unlike many other members of ISO or national standards bodies, ANSI is not a government agency, nor do we develop standards ourselves. However, we are the designated US member to ISO and via the US National Committee to the IEC. And about ISO as an organization, ISO is a network of standards bodies, national standards bodies such as ANSI, that come together to develop and publish the policies and standards of ISO. But it is not just the standards bodies and the staff of them that participate in this effort. Instead, through rigorous stakeholder engagement and due process, representatives from industry, government, academia, consumers, and really any affected stakeholder also participate. So for example, when ANSI is participating in any ISO technical committee, we have a process to ensure that our national mirror committees to those ISO committees are well balanced with representations from all these stakeholder categories. And oftentimes in the meetings, it is not ANSI staff that sits at the technical committee or the working group table. It is a representative from one of these categories that's been nominated by the mirror committee. So these experts contribute directly to the technical content and the writing of the standards. And that's the process that ANSI follows, but most ISO members from around the world follow a similar process. So it really engages stakeholders from a wide variety of categories and expertise and practices, as well as countries. In the development of ISO standards, ISO has set out a set process that each committee and each document must follow. And it's not important to go through the exact names on this slide, but this is just to show you that no matter what standard is being developed, it follows the same process, and this has been set by ISO. And it is confirmed before publication that each drafting stage was accomplished, that comments were resolved at each stage, and that the appropriate notice and comment periods were given at each stage. So ISO 30500 was developed using this process by an ISO committee. That committee was called Project Committee, or PC 305. And Project Committee just means that that committee was only developing one standard. So it's the same as a technical committee, except that most ISO technical committees are developing many standards instead of just one. So that's the only difference between PC 305 and others. And PC 305 was established and followed the same process to develop the ISO standard as outlined on the previous slide. So it began in 2016 with a new work item proposal, or a proposal for the new standard, that was circulated to all ISO member bodies to vote on whether or not that standard should be developed. At this point, there was no committee. All ISO members had a chance to vote on whether or not the standard should be developed. The vote was successful, and so PC 305 was established, and it began work right away and held its first meeting in 2016. I should mention that ANSI, along with ASN, the standards body of Senegal, served as the secretariat for PC 305 and led the work in developing the schedule and sending out the comments and drafts to all the committee members throughout the development of ISO 30500. So the first few meetings that you see here were hosted in the US and in Senegal in light of that, because we were serving in a twinning arrangement as the secretariat. But throughout 2017, the committee worked through all of the other required steps, publishing interim draft ISO documents and resolving comments and holding meetings of the PC 305 in order to lead to the eventual published standard. And after the final draft international standard was circulated, that meant after all member bodies voted on the publication, it was established on October 1st, 2018 as ISO 30500. And there's a footnote to that at the end that ISO standards have to be reviewed every 5 years. And since the standard was published in 2018, that means that this year is the 5-year review period. And just a few months ago, PC 305 was reestablished by ISO and has begun the work to review ISO 30500. So standards development at ISO and PC 305 in particular really is a global effort. You can see through this map all of the countries that participated on the first iteration of PC 305 and developed ISO 30500. With the new committee established, it is gaining members as well. And so if your country is not represented yet on PC 305, there is still time. And I encourage everyone to double check whether your country is currently a member of PC 305. You can get involved either way by contacting your ISO member organization or national standards body. And if you don't have their contact information, the link in this slide will help you get to that organization and their contact information. So after the webinar, if the slides are shared, you can get access to those contacts directly through this link. Before I close, just a couple of other notes about resources that are available to learn more about this process that I've just briefly described today. The first is a video and a series of videos that ANSI has led the development of. In 2 minutes or less, sanitation standards are explained in easy to understand language. So we have videos on sanitation standards, on ISO standards, and other subjects that are available on our YouTube channel. And there's a link to the English version on this slide. And the full suite of our resources can be found on our website, sanitation.ansi.org. We have a toolkit of information all about ISO 30500 and other international non-sewered sanitation standards. Information is available in English, French, and Chinese, and it includes presentations, videos, and other materials. Thank you very much. That's all that I have for you today, and I am sure that my colleagues at CWAS-CRDF will include a lot more information about the details and the scope of ISO 30500. Thank you very much, and I wish you all the best for a good webinar.
Thank you, Leslie, for giving us a brief on the overall scope of this standard. Moving on, now we will be touching upon there will be 2 sessions as such by Chris Chan, where first we'll be touching upon the technical requirements of this ISO 3500, and later on we'll move into the certification process, which I believe most of you would be much interested to know about. Chris Chan is a project manager at CWAS-CRDF with several years of experience in ISO 3500. He was also a technical lead in the development of ISO 31800, which is another complementary standard. Through his period with CWAS-CRDF, Chris has been validating these 2 standards, working with manufacturers as well as laboratories to bring up their capabilities in several geographies, including India, China, South Africa, and other African countries. Currently, Chris, with his team, is working on the certification of the first 3500 product, as well as the first 5-year systematic review process for the standard in the capacity of a project lead. Otherwise, Chris is a certified trainer for Skill Future Singapore courses, as well as a master trainer for Green Compass. Chris holds a bachelor's degree in chemical engineering from Australia. and has worked as project manager for several years on desalination, wastewater, energy audit, and other related aspects. Over to you, Chris.
All right. Thank you, Dr. Sarush. So, good morning, good evening, good afternoon, everyone. So I'll go into the details, technical details on 3500. It's a bit dry. I've tried to do my slides as interesting as possible, but please bear with me if it's a bit dry. So yeah, so the introduction of 3500. Next slide, please. So we'll start with the overview of what ISO 3500 is about. So first of all, the entire certification, the certification bodies have to be accredited, and all the laboratories doing the testing needs to be accredited as well. This is specified by the standard itself. And then, as you can see in the diagram over here, is a very summarized diagram of what a non-sewered sanitation system is about. So the input would be feces, urine, and water if there's flush on the left. And then the system is evaluated on a lot of aspects. They can be mechanical, and then it can be electrical and even electromagnetic compatibility requirements. So, and the output side is where I think a lot of you is more interested in is the solid discharge, the liquid discharge, the air, the odor, and the noise. They all have requirements for all of them. Okay, so next slide, please. So there's the timeline for the entire testing, which I will go through in detail in my next presentation. But overall, the standard requires, as mentioned, is broken down into class 1, which is non-biological systems, and then class 2 and 3, which are biological and any other systems which has more than one front end, the largest systems basically. So the class 1 is basically a controlled laboratory testing for 32 days, and then a field testing for at least 1 month or 30 days. And then class 2 and class 3, we have similar controlled laboratory testing, 32 days, and then a field testing of 5 months. So as you can see, the bottom right pie chart is a sort of our estimate or our summary of how much commitment for either the certification team or the manufacturers or the laboratories need. So you can see the main chunk would be coming from the controlled laboratory testing. A lot of work needs to be done in that aspect. And then you can see the document checks and field testing as well, almost equal. And then you have some front-end testing as well if there's a front end for the system. So this is just a summary. And then next slide, please. Okay, so going into the standard itself, the standard is really huge. I managed to sort of break it down into 3 sections. The document text, there's a lot of documents that needs to be checked throughout the entire certification. Certification team will need to request from the manufacturers based on the clauses what documents is really required, because all the systems is very different. It could be a combustion oxidation system, it could be an electrochemical system, it could be a biological system. So every technology that we certify is there's no standard process. There is a standard process, but it's always a different story whenever we do certification because of the various technologies. So document checks, after we study the system, we will request from the manufacturers based on the clauses what needs to be provided. Okay, this is number 1. But I won't go through the details. It's very dry over here. If anyone wants the more details, you can review the standard itself. But it's basically broken down into these subcategories. And then today I'll go through more on the controlled laboratory testing, which is the bulk of the testing required, and I think would be the most important or difficult part for the manufacturers, because it's basically based on the design of the system. And then of course the field verification of performance. So the first one would be controlled laboratory testing, loading patterns. We have the different loading patterns when we do the testing for the system. If you can go to the next slide, please. Yeah, so there's a schedule provided in the standard, which looks like this. As a gist, if you can see, if I go through a quick one, on the first column, you see the test procedures. It shows on which day, which test will be done. Is it for solid and effluent? Is it for noise? Or is it for odor, for example? Okay. And then for the second column is when, what kind of loading pattern would it be? Would it be normal loading pattern? Would it be a diarrhea day? Or maybe would it be an overload day? Maybe there's a party on that day. So the entire schedule mix and matches and tests the system vigorously to ensure that it goes through the entire 32-day testing, that all of them have to pass the requirements. And then, of course, the third and fourth columns, as you see, is the day number and how many days it takes. So as you can see, the last row is almost 32 days minimally is required. So this is required by the standard. It's not required by the certification body. Okay, so moving on to the next slide. So I have as much pictures as possible to not bore you guys. So as you can see, the loading will be done manually. People weigh the amount of feces and urine and then loads into the system. And then you can see some calculations, example for 3 kg system and 15-liter urine system. And then they are all loaded at the different times as you see, as required in the ISO standard. Okay, next slide, please. So that's the loading pattern, the normal loading. And then you have the stress loading pattern or stress loading days as well. And then you have the formula there. And then next slide. And then you have, of course, you have the diarrhea days where it assumes that maybe the entire household, half of the people gets diarrhea, for example. Okay. And then next slide. Yep. So the front end requirements, as I mentioned in my first few slides, there's requirements for testing for the front end, which is a toilet bowl or the squatting pan, if it's a squatting pan. So there's a visibility of feces, evacuation, mechanism testing, etc. So they all follows the sort of a reference EN standard for this kind of front ends, which I'll not be going through. I'll be going through the other environmental, human health, and other requirements. So the environmental side, we have 5 requirements at the moment. COD, TSS, TN, TP, and pH. It's quite basic requirements that any discharge have to comply to this standard. These requirements. Next slide, please. So these are the values that required before or when the effluent gets discharged into the environment. So if you can see, the environmental parameters doesn't include the solid because when the committee developed the standard, the solids was left out for the environmental because there were debate or arguments that the solid could be used as a fertilizer, for example, or be used for other purposes. So they would like to keep the nutrients in the solid as much as possible. But of course, the nutrients in the effluent have to be removed in case there's a illegal discharge out into the open or even the rivers, etc. Okay, next slide, please. And then we go to the human health parameters, which is one of the difficult parts that we, from our experience. We have 4 pathogens in here. So we go to the next slide. So the microbial testing is basically 4 pathogens: the bacteria, the virus, helminth, and the protozoa pathogens. So what is being tested here is not only the testing. If you can see on the right side, before input is being put into the system, we spike the amount of pathogens into the mixture that is equivalent to what's required in the top left table on the slide. So you can see during the input, the spike have to be 10 to the power 8 for E. coli, 10 to the power 8 for MS2, 10 to the power 4 for Ascaris-Sam, and then 10 to the power 6 for Clostridium perfringens spores. So it has to meet the concentration of pathogens in the input, and then it has to meet the log reduction at the output, which is S2 you see on the diagram there. And then the bottom left table, as you can see, is the thresholds. There's two criteria for it to pass. Whatever is coming out have to meet the threshold, which is you can see the maximum concentration in solids or liquids. And then it also has to meet the log reduction value, meaning the input minus the output. Okay. So this is one of the most difficult part of testing, because a lot of pathogens is required. Depending on the system, the larger the system, the more spiking material is required. And then these are some photos we've done for testing for some certain units. Next slide, please. Okay, so and then at the air emissions portion, we have the indoor air emission and the outdoor stack emissions. So as you can see, the indoor for indoor safety for users, carbon monoxide, CO2, NOx, H2S, etc. And then you see the stack for the next slide. Okay, sorry. So the indoor emissions, these are the requirements. And then as you can see in the next slide please. You can see this is how the test setup is being done. So we have test setup in the front end, which is the indoor. And then we also have this is not required by standard, but we have a sort of a background noise testing for air emissions, because we feel that we realize that if it's outside the lab for testing, there's some outdoor air pollution that might interfere with the testing results. Okay. And then you have the stack emissions as well. These are the parameters where the consideration is where if there's a stack emission, the surrounding people, will it be bad or good for the people? Next slide, please. So there's a requirements for the stack measurement, and then basically it's just a emissions requirement for stack measurement. It's very common for air emission testing. And then you can see the values for the parameters, which is given by the standard, and the standard always comes with the threshold and the test method, recommended test methods as well, just to guide the users how to do the testing. Okay, so next slide, please. We're going to the acoustic or noise testing. Basically, similar to the air emissions, we have the internal testing and the external testing as well. And then you can see the next slide. Yes, so you can see how it looks like. If it's an indoor emissions testing, is basically a microphone above the seat pan of 1.2 meters. And then next slide, please. And then you can see there's the back-end testing for any systems with the center point, and then the measurements will be 1 meter apart. So if the system is very big, every 1 meter apart, there will be one microphone testing it. And then the requirements would be a 60 dBA average requirement for 24 hours. And then at any one time, it should not go past 85 decibels. Next slide, please. Yeah, so to have a understanding, this is what the noise testing looks like. So if you see this is, I think, a 20-foot container. You can see almost about 6 microphones on each side of the container. Okay, so similar to air emissions and noise, we have the odor, which is also indoor and outdoor testing. Next slide, please. Yeah. So the testing is using panelists, people to sniff the environment. So these people are being assessed before even going to site to do the testing. They will be assessed on how sensitive their nose is. So there's a test method in the standard to verify these panelists that their nose are not too sensitive or not sensitive enough. Yeah. So as you can see, in the middle photo, this is the odor screening, where they sniff different bags of H2S to see if they can detect using their nose. So once they pass the test, they will go down onto site, which is on the right photo, where they go around the container and then or the system and do the sniffing based on the standard. Okay, yeah, and then last but not least, for the controlled laboratory testing, one slide before, sorry. Yeah, so the electrical requirements is very minimal. For the ISO 3500, the electrical requirements are basically the control system. There's a guideline for control system if there's one. And then the energy discharge, basically it has to be able to discharge its energy after it shuts down the system. Okay, and then next slide, please. And then going to the last few slides for the this presentation is basically the field verification of performance, which is the after the controlled laboratory testing, the unit will be sent to site to do further testing on field, which is basically opening up to the public to use the toilet. So class 1 will meet 30 days as mentioned in the first few slides. And then class 2 and 3 will take 5 months. Yeah. And then basically there's only environmental and human health testing for this period. And you can see this would be the schedule of how the testing is. Environmental for class 1 will be a weekly testing, and human health will be weekly as well. But class 2 and 3, as you see, is a weekly testing for environmental, but only a monthly testing for the human health. Okay, next slide, please. So the entire duration for the testing is similar to the controlled laboratory testing. The only difference is the environmental, you have a leeway to have a 75% pass requirements. And then for the human health, the entire duration have to pass for the bacteria, protozoa, and virus. And then helminth is removed from the field verification performance because the experts felt that protozoa validates the ascarisum testing during the field testing. Okay, yeah, so thank you very much. These are some of the photos we've done testing around for the past few years. And then without further ado, I'll hand it back to Dr. Sarosh.
Thank you, Chris, for briefing in detail about the requirements and technicalities of the standard. I suppose the certification process would be the one which would be more interesting to all our stakeholders. Let's move on to that. Over to you, please.
Okay. Thank you, Dr. Sarosh. So my next few slides will be very short. It will be very to the point, and I think, as mentioned by Dr. Sarosh, I think a lot of people want to know the facts of certification, and then this is something that I think this is the first time I'm sharing this. Because as more information, as the time goes by, we have more information. This is some of the stuff that we managed to put together and update. So what happens after standards publication? I'm not sure if everyone knows. After the standard is publicized, there's two routes. If the standard body adopts, or the national standards body adopts the standard, then we'll go to route A. So the national standards body for India might be the BIS, South Africa will be CEPT, China will be CNAS, etc. And then you have Senegal as ASN. So once the standard body adopts the standard, the certification body can create a certification scheme and then apply to the national standards body to put their mark into their certificate. So at the end of the product, the end product will be a certification body certification of ISO 3500 with a certification body mark and NSB accreditation mark in the certificate as well. This is route A, the first route. And then there's also, to be honest, there's some countries who might not have adopted or haven't adopted the standard. Then there's actually a second route where it just goes through the certification body. For example, we can issue certificates as well because we are accredited to issue certificates. And then similarly, the certification body will have a certification scheme, and then we can create a certification and with a mark as well. So the difference between route A and route B is just without the NSB accreditation or mark. But whenever there's a adoption, the standards body will probably use these requirements as a regulation or certain requirements for the country. So if there's a standards body accreditation, it would be best to adopt NSB's requirements in the country. Okay, next slide, please. So this is how a typical certification is like. From the left column, you manufacturers submit application, and then we plan, evaluate, and then we have the testing in the middle. And then in between, we have factory surveillance to ensure that the manufacturing and quality of the manufacturer's factory are there, so that the repetitive manufacturing of the similar systems are of quality. Okay, then after that, once all the entire testing is being done, the certification body will review all the test results and then issue a certificate. Next slide, please. So, okay, so this is with regards to 3500. As you see, the last presentation, the testing is ginormous. There's a lot of testing required and a lot of days required for the testing. So in a gist, this is a very rough estimate of how it looks like. Preparation phase for certification body to really understand your system, to talk to you, to come up with a test plan, where to take samples, where to do spiking. All these plus minus will take 3 to 4 months. So you can see on the last column, the responsibility. Most of the responsibility, sometimes you see, comes from the manufacturers, especially the testing phase. So if you see the testing phase, it goes through the entire requirements as what I shown in the last presentation, it takes about 3 months. And then you have the field testing, which was the last few slides from the last presentation, is 1 month, 5 months, and 5 months, depending on the class. Okay. And then, oh, sorry, on the same slide again, the previous slide. Yeah. So before the issuing of the certification body had to prepare as well, and then it takes 2 months, 3 months, 2 months and 1 month to provide the certification, and then you can see the estimated total time below on the table there. Okay. Next slide, please. Thank you. So how the certification looks like. The actual certification looks like this. If the full certification is done, you get a certificate, as you can see on the right. And then you can see the marks, which can be pasted on the product directly to say that it is fully certified for ISO 3500. This is what it looks like. And next slide, please. And then this is an alternative which we haven't provided, and usually we need to discuss with the manufacturers the use for it. If there's not much use for it, we wouldn't really advise you to go. So this alternative would be a certificate of conformity, or in layman terms, it's just a partial certification. And it will only be certified to certain clauses in the standard. So saying that, sometimes it really depends on what clauses you want to certify to and why. Maybe there might be a buyer that requires you to comply to clause 567 in ISO 3500. Maybe. Then we can do a partial certification for it. Okay. And then second alternative, as you can see, the cost is very high. The duration is very long. Whenever there's a testing that fails in the middle of the testing, we need to redo everything again. So we do not usually recommend someone who has not, or manufacturers who has not done their internal testing to go for full certification, because high chance there might be some things that they might have overlooked design-wise. Maybe they haven't really encountered helminth spiking at certain levels before, and then maybe the systems cannot handle. Maybe the process duration just have to increase to cater for ISO 3500. So these are some things that we need to be aware of. And then TUSUD, we created a sanitation readiness index, which helps. It's just basically an online platform to check, and is a self assessment for manufacturers to fill in to check whether it is close to certification or the gap is very wide. So this is just a tool for them to have a look before going to full certification. Yes, and I think before going to the last slide, yeah, I think we have some questions that was posted before that. What's the renewal for the certification? Currently for TUSUD, it really depends on certification to certification body. But currently for TUSUD, it's about 3 years. Then you need to do a renewal of certificate. But you do not need to do the entire full testing again. Basically, you only need to have a factory inspection and also some minor testing, just for us to verify that the systems are working in good quality order. So this is something that I wanted to highlight as well. So without further ado, then I'll be ending my presentation, and then we can take some questions later. So I'll be handing it back to Dr. Saurabh. Thank you.
Thank you, Chris, for delivering the details of the intricacies related to certification. We move on. We already heard Sun giving us the importance of the need for this standard. We'll again hear from Sun on the experiences, the country experiences, learnings from the implementation in US, South Africa, and possibly other experiences. Over to you, Sun, please.
Thank you, Dr. Sarosh. Yeah, hello again. And so in this segment, I'll get into the implementation of the ISO 30500, and I'll try not to repeat what others have spoken about here. And so next slide. I'd previously mentioned that we'll be getting into some examples of that supportive regulatory environment. But before getting into that, I'll also like to show you some examples of integrated treatment systems that are designed to comply with the performance standard that Chris just mentioned. And these are publicly available information. Anyway, and then next slide. So Chris just explained the details of ISO 30500 as well as the certification process. And it may seem dry, but the reality of it is super important, because it helps to make it ensures that the products that are in fact certified are safe for human health and the environment, and also pleasant to use. If you think about the noise aspect and the odor aspect, so you can have wonderful machines that do wonderful things, but if nobody wants to use it, then it will go into disuse and not really survive in the marketplace. So super important. And I would like to just mention one thing. The actual user, if you could go back to one slide, and if you want to, as the user, you don't need to get into the details of this. It's the developers and the manufacturers and the regulators that have to deal with the specific aspects that Chris mentioned. The user just has to be given the assurance that a certified product with a certification mark is in fact safe, and also they will be able to assess its use and its aspirational aspect. So, and then in this diagram, please keep in mind that compliance systems over in the front end side, whether it's a seat or whether it's a squad plate, may be connected to one front end, such as in a home, small home, or maybe connected to multiple front ends, such as in a larger home or larger building, such as an apartment complex, in a school or something similar. More of a community scale type of a system, or some people may be aware of package plants that may be at the basement or lower floor of an apartment complex. So next slide. So there are multiple efforts underway by developers and commercial entities to prove out and demonstrate these toilet systems. The picture I'll show you later and what's listed here are the community scale, the bigger systems that are currently being demonstrated in India, China, South Africa, as well as Thailand. And then the next slide shows such systems. Next slide, please. And these tend to be like bigger container-based systems. Typically, the bigger systems tend to have a big biological component, as well as other disinfection elements. These systems are designed by Envirolu, WEC, Clear, Siam Cement Group in Thailand, and EcoSan. And there are also a number of others, but again, this is what I can publicly share with you. And then the next slide shows the units that are being demonstrated for household scales, really household appliances. And this is being done in India, China, South Africa, Indonesia, the US. They really are, in fact, if you go to the next slide, they are essentially home appliances, something that you would have no problems installing inside your home, because unlike pit latrines and some other systems, you would struggle with smell and leakage. These are intended to be fully tight, watertight, airtight, and also to fully treat the system. So you can see on the left hand, the Cranfield circular toilet, picture of that next to a household clothes dryer. And it includes the front end receptacle as well as the actual treatment system. That's really the size of it. It's actually quite amazing. And then there are other images of the Georgia Tech Generation 2 reinvented toilet and firelight system. And please keep in mind, these are just examples of some of the systems currently under development and demonstration. There's others being developed, but because of commercial, proprietary, and limited information, cannot necessarily be shared with you. But more are coming. So it's quite exciting, actually. So getting back to ISO 30500, next slide, please. Chris mentioned about adoption and the paths to certification. Oh, if I could take a second back. In terms of certification, I think there was a question about costs and duration. It is expensive and does take a while, but the idea is that if you're just going to build 5 or 10 units, by no means, you do not want to go through the certification process. But if you're going to be building hundreds of thousands of units, then you could imagine the cost of the certification can be spread over the multiple units. So hopefully, if you amortize it, it's less than $1 per unit if you build enough units. So that's where the real payback is in building lots of systems, and again, driving out the cost. Sorry about that little detour there. So the adoption map. So far, 29 countries and 2 regional standards organizations have adopted ISO 30500 for implementation use. And China is going through a multi-year effort to nationally adopt the standard. And SAC with their partner Huanka in Shanghai, they believe they're within maybe end of this year or early next year that the ISO 30500 will be virtually identically adopted in China. And so that's really exciting news. But after national adoption, so what? What's next? Well, it's important to use the standard for design and build, of course, but also to integrate it into plumbing and building codes or regulations. So some examples that you see right here, in South Africa, after the standard was nationally adopted as SANS 30500, so SANS 30500, their national building regulations for non-sewered sanitation was revised to add SANS 30500 compliant systems as another alternative to existing chemical toilets and ventilated improved pit latrines. So if you go to the next slide, this is a screen print from the South African National Building Code showing SANS 30500 compliant systems as acceptable systems. And this building code has been applicable since 2021. So really, South Africa is ready for these certified compliant products to be installed. Now it's a matter of commercializing and mass scale production of these systems. So they are legal for use in South Africa today. Another example will be the US. So in the US, the ANSI, you heard from Ms. Leslie McDermott from American National Standards Institute. So it's an ANSI, Canadian, IAPMO, ISO 30500. And those compliance systems are included in Appendix O of IAPMO's 2024 Uniform Building Codes. And it is available today. Now, in the US, it's a little bit different. US and Canada, even though there's a model code, it requires every state, county, and some of the bigger cities to actually include them in their own plumbing and building codes. So it's very segmented, very fragmented, and I know there are other countries that are like that. Whereas the opposite is that a country at the top level, once they integrate it into their building code, it flows down to everybody. So different countries approach it differently. So the next slide is just a screen print of what that Appendix O looks like. And as you can see, it lists ISO, well, ANSI, CAN, IAPMO, ISO 30500 as the systems requirement for these particular type of non-sewer sanitation. So once these get implemented into state and local regulations and codes, then they will become in fact the law. And so the next slide is, so IAPMO is one organization, international organization that has these model codes. The International Code Council, ICC, is another one. And they have implemented IAPMO, ANSI, Canadian ISO 30500 into their plumbing codes, plumbing model codes, international residential building codes, and private sewage codes. So again, these are model codes that some US states, some Canadian provinces, and some other countries are free to use to incorporate into their own building and plumbing codes. The next slide is just an excerpt from one of the International Private Sewage Disposal Code for 2024, but again, available today, listing IAPMO/ISO 30500 as an alternative to National Sanitation Foundation, or NSF's 40. So what this means is that both these codes are available for inclusion. And like I said, US, Canada, and other countries are free to use these and start to put them into their own building and plumbing codes. And it's important to ensure, one thing that I want to make very clear is that inclusion in codes and regulations should not, must not, does not limit existing systems. You really want to allow compliance systems as an alternative, as an acceptable option to what is already considered acceptable. So, and then just to let the choice be up to the consumer and whoever is purchasing, if it's a government entity or some other organization that are purchasing and subsidizing en masse. You really do not want to reduce what is available to address the sanitation crisis that we're in today. And it will ultimately be the customer preferences and the market conditions that determine what are most suitable. And I would I reach out to all you on this webinar, along with all your colleagues, your organizations, and your regulators, to understand that the need for safe sanitation to protect all people, the environment, and clean water. I think we all understand that. The question becomes, what is the best way to implement that? And it's to keep the solutions as widely available as possible. So next slide. So I would ask that we all keep learning together, working together to benefit anyone, especially those today who are suffering from the lack of safe and aspirational sanitation. And these are some links. I think Leslie mentioned the ANSI sanitation, great reference, great deal of information. I know non-sewered, that's Sustainable Sanitation Services link. So I'd ask the supporters of this webinar to make these links available, and some other publicly available videos and references. So with that, thank you so much, and thank you for listening. Today and in the future, we can work together and make a huge difference. So thank you.
Thank you, Sun, for giving out a whole lot of experiences, diverse enough to include organizations like IAPMO and other partners who have been developing standards for plumbing and other associated services.
Thank you.
After this final session for the day, we are moving to the question and answer session from the participants. We propose to do an open session wherein, like, those participants who wish to put in their questions can raise their hand, and we'll be calling out them one by one, and they can choose the speaker for the question.
Yeah, maybe looking on the chat, I see one question about how the market is functioning for home appliances. Do they follow ISO certification first, or do they launch a product first? So maybe I'll jump in on that real quick. So imagine your cell phone. You know, I believe everyone on this call probably has a cell phone or a mobile phone. The level of testing for cell phones at the component level, as well as at the unit level. You know, you'll notice on the back, or if you look at the product, there's a tremendous amount of testing, whether it's UL, CE, ITU, International, I believe, Telegraph or Telephone Union, have requirements. So not necessarily ISO certification, but there are lots of certification going on. And then every country will also determine what is and is not acceptable from an emissions perspective. So, yeah, anyway. Dr. Sarosh, you're muted.
Oh, thank you, son. We have, and thanks for answering that. Dhruv, we find that you had a couple of questions. If you could put in on yours.
Yeah, thank you. I think it was excellent presentation, soon. I just wanted to understand you mentioned about some country has an early adoption of the ISO standards and some are not. But in the real practice, would that be the technology readiness and the market readiness would be the first step, or ISO adoption by the country is the first steps? What should go first and second? So that is one. And the related question is that you mentioned about the home appliances and the development is taking in AI and the generative AI in the home appliances, etc. So would that be, what is the market is following the processes for certification? Would they, so what are the learnings from that systems, and whether the product has been launched first, or it has been the tried and tested in every environment is the first priority? So what is the lessons from the other similar alliance activities, and how our sanitation system is different from the other systems, and what are pros and cons of learning from the other allied sectors?
Great question. To your first point about, you know, what happens first, the chicken and the egg conundrum. The reality of it is you can normally, the standard is not even written until products start to come out and they start to fail and hurt or kill people. That's typically when requirements and typically when regulators get involved. And also that process of a recognition of a need of a standard in an industry is as the industry is developing. The problem is that the industry for sanitation, there is one for sewer sanitation, and it has its place. There's big money there. Typically, non-sewer sanitation, the industry is very limited, especially in developing countries. So there really is no industry. So how do you develop the industry? You know, and so the idea is normally products would come out. It would be a recognition that there's a need to regulate and certify, and then you would end up getting there. And the industry would mature. But that can take decades, or it may never even happen. And the sanitation crisis is so urgent that there's a need to really be innovative. And in fact, the Secretary General of ISO, Mr. Sergio Mujica, at one of the, I think the Beijing Expo in 2018, talked about the innovation of ISO 34500, where a standard was actually created before products were even available. That is very upside down. But in order to resolve, to fix, have any chance of fixing this problem that's plaguing half the population of the world, you really need to do something different. And that's the idea here. Why certify it before? There is no need to certify the system, but will it give people the confidence that the system is actually working to kill pathogens? I can't tell whether our system is killing pathogens or not until my kids are getting sick or until I get sick. So the idea is even that, to certify first, ideally, or design systems that meet the requirement, because without the requirements, you could build a pit latrine and say, I'm a great toilet. I could have a composting toilet and say, I'm a great toilet. There are lots of people who are saying that today, and I can tell I'm going along on this, but and then I think I did try to answer your second question. So if you're building 10, 20, 30, 100, or 1,000 of these systems, per unit cost will be quite expensive for certification. You really need to spread the cost over hundreds of thousands of units to make it just dollar, a US dollar per unit. So I hope that helps. Thank you. Yeah.
Thank you, sir. Chris, your views on the certification part of it?
Yeah, I think Sun covered most of it. I think the question kind of came from the sort of the supply side, the manufacturer side, the company side. But actually what we usually get is from the demand side. Whenever we go to conferences, just want to share as well, we get approached by a lot of buyers, a lot of philanthropic organizations, etc. They come up to us to ask us, hey, Chris, what's the best system? We usually don't have the answer. What's the best system? What we can say is, what's a safe system? A safe system is something that, is tested to be safe, and tested to what means we have a standard to test to. The thing is, to be honest, I think a lot of our colleagues know as well, there's no technology that's been certified to ISO 3500 yet, but we are in the midst of certifying a few. Hopefully we can get one or two out by the end of the year or maybe next year. Yeah, so you have to weigh the side on the buyer side, what's the demand for such systems as well, to weigh in whatever the original question is about as well. Yeah, thank you.
Thank you, Chris. We see a question from Ravi Shankar. Ravi Shankar, if you could please put your question through. The question reads, at what level this can be cost competitive or commercially viable? Alternatively, what can be the per capita cost if the system needs compliance to ISO 3500? This was the question put forward to us. I'll first put it to Sun, and then maybe Chris can add on to it.
Could you repeat that question? I was reading, I think
The question reads, at what level this can be cost competitive or commercially viable? Alternatively, what can be the per capita cost if the system needs compliance to ISO 3500?
Yeah, it'll really all depend on what the product design looks like, the cost of build, and clearly, if you're only building handfuls or hundreds or even thousands, they will be quite expensive. Sorry, I keep going back to the handphone analogy, but I remember when the first handphones came out, they were in the US, several $1,000s, and they were the size of a small suitcase, and you had to keep it plugged into the car. Several thousand US dollars in 1980 or 1990 dollars. That's today would be, $5,000, $6,000, $7,000 today. And we now carry around in our pockets supercomputers. Remember those, you could only call somebody, and you had to, it was very limited. And can you imagine if somebody said back then, oh, $2,000 transportable mobile phone, no, it'll never take place. There were people who thought that. Today, nobody in the world is waiting for a thin copper wire to go from one home to another to an exchange because there is no need for that. So that's the idea. I know these toilets are different than a cell phone, but there are some similarities that I think we will see. So, yeah, I don't know if was there a second question?
I mean, Chris, I mean, any additions to this?
No, I think yeah, Sun covered most of it.
Yeah. I mean,
I think Heinz Peter asked the question, does the ISO 30500 include dry toilet systems with front and respective integrated treatment backends? And the answer is, yeah, I mean, as long as it meets all of the ISO 30500 requirement, it is technology agnostic. So it doesn't define it has to be a particular type of a treatment, as long as it kills the pathogens and output is environmentally friendly. In fact, I think Cranfield has a system that is very close to a dry toilet in terms of it uses very, very little flush water. I think in terms of, you know, several hundred cc's or several hundred milliliters to flush. But it is ultimately, when I think of a dry toilet, I oftentimes think of like a composting toilet. And today I'm not aware of a composting toilet that would meet the requirement, but maybe there is a technology that could in the future. Yeah. Thank you.
Yeah. Thank you, son. In the spirit of time, we are moving ahead with a vote of thanks. I mean, we see that there are a few more questions which you people may be willing to ask us. Please send it to us. We'll try to reply to your queries. Now, let me ask Asim Mansoori from the CWAS team to deliver the vote of thanks. Asim ji, please.
Yeah. I think thank you everyone for joining, and special thanks to the organizers, both our partners, IIT Palakkad and the Gates Foundation. And thanks Chris, Sun and Leslie for championing the sessions. I think we heard the first webinar, which was actually like a scratch on the surface, but today's webinar, which deep dived into ISO 30,500 was great. So thank you for your sessions. And thank you all the participants for staying back. I know we have gone a bit off the time, but we hope to manage this during our next set of webinars as well and carry on this momentum of sharing, because the main premise of doing this series webinar was to more share and create awareness around ISOs. We are also learning along with you as we move ahead, and we hope to continue this learning journey. And we will be sharing the presentations and the audio recording with all of the video recording of the sessions with all of you. And we hope to see you in the next set of webinars, which are going to talk about the ISO 31800, which is around the treatment technology towards the end of the service chain. And we'll also be talking about, I think, what Sun highlighted about some of the RT technologies. We are also going to show you some of the OP technologies that have come up under the transformative technologies work that the Gates Foundation is doing. So we look forward to seeing all of you again. And thank you for joining. Namaste.
Thank you, everybody.
Thanks, everyone. Yeah, bye.
Thank you.
Thank you.
Thank you.
Thank
And your
you.
wonderful questions. Bye for the day.